A Smurf attack is where a bunch of little blue people come and attack your network. I'm just kidding. Smurf attack is a distributed denial of service attack. Large numbers of ICMP packets. So again, this is on the test. ICMP Smurf. ICMP Smurf. A large number of ICMP packets with the intended victim's spoof source address are broadcast to a network using IP broadcast address. Most devices will respond by sending a reply to those source IP addresses. So you talk to the machine, it bounces it back to all these other machines, and then they talk back, and you keep doing that, and it gets more and more amplified, and as a result, a DDoS will result. You start consuming the resources, the number of open connections on that machine, it'll take it down offline. It doesn't really go offline. It could cause a crash, but most likely it'll just be so busy answering those calls that the people that are really trying to talk to it can no longer talk to it. It's an old type of attack. Many basic security devices will protect against this attack. It may still work on the Internet of Things types of networks and industrial environments where they have older gear. In 1999, routers and switches were pre-configured not to forward those types of packets, ICMP packets, right? Smurf amplification networks exist today, so they're still out there. They're mitigated by disallowing pings on a router. A Fraggle attack. A DOS attack, it's a type of denial of service attack that sends a large amount of spoofed UDP traffic, Fraggle UDP, Fraggle UDP, Fraggle UDP. This is a test question. DOS attack that sends a large number of spoofed UDP traffic to a router's broadcast address within a network. It's mitigated by disabling broadcast on switches and routers. It results in an amplification, if successful, of responses and through denial of service, as the machine will slow to a crawl for anyone trying to use it. Again, an old type of attack. Many basic security devices will protect against this. It may still work on older industrial environments and maybe some Internet of Things routers. Like in a physical plant of a company, they may have really old gear. Oh, our network's slow, I can use my old router from the house or whatever. Some of the specialized devices may not have these new security tools built into them, or these things disabled by default, and these things can occur on these old industrial environments. Or maybe the new industrial environments if they have, really highly specialized gear. A teardrop attack. It's the sending of mangled IP fragments with overlapping, oversized payloads to the target device. It can crash older stack implementations. It affects Windows 95, Windows 3.1, NT, Linux 2, Linux 2.1 kernels, older devices that are connected to the internet. There's many older devices still connected to the internet, so the teardrop still works on there. It's the sending of mangled IP fragments. Teardrop mangled, teardrop mangled. Try to remember it that way. The ping of death. Again, this is an older attack. It may still work on older or highly specialized devices like Internet of Things and industrial environments. It's comprised of sending a malformed ping to a host. Any IPv4 packet may be as large as 56,535 bytes. A malformed ping of death packet is larger than 56,535 bytes. That's the key for the test. You will see a packet larger than 56,535. Automatically, you know the answer to that is ping of death. This test does try to trick you, so make sure you read through all the questions. You have plenty of time to take the test, so make sure that you read through all of the questions. Also, select the answers, take your time, read through all of them carefully, because as you read other questions, they will kind of hint to the answer if you selected the wrong one. It's kind of context sensitive. So if you start seeing the same question over and over and over, you may start to rethink, whoa, maybe I answered that one wrong, because why is it asking me the same question over and over? It's trying to tell you that you picked the wrong answer. So the packet for a ping of death is larger than 56,535. It causes a buffer overflow when reassembled on the other end of the connection. So they send this huge thing, and when it's reassembled on the other end, it results in a buffer overflow. We know that buffer overflows were very common in the past and that they've been remedied today, so it's not a very useful attack today. It may facilitate injection of malicious code. It's an old attack. Many basic security devices will protect against this today. It may still work on industrial, older environments, highly specialized environments. To protect against this attack, the sum of the segment offset and total length field in the IP header of each fragment is smaller than 65,535. If the sum is larger, the packet is invalid. Many firewalls will perform this check.
So for the test, there's a couple of ping commands that you need to be aware of. You're going to see test questions about this, probably literally like this. One of them is what ping command lets a tester enumerate live systems in a Class C network via ICMP using native Windows tools. Again, we're talking about the sliding scale, so which native Windows tools? So just be aware that this is the answer for the test, and this will work on older systems, 98, XP, NT. In modern OSs, you would use some different shell scripting to do this, and PowerShell. And PowerShell is very powerful, and it's actually a pseudo programming language, so it's incredibly powerful for the modern OSs, and we'll talk about some of that later. And the second one you need to be aware of is how can ping be used to fingerprint a web server? So you would telnet to the web server address, port 80, and then you would type this head/http 1.0. And this will trigger the web server into returning the page, and then you're going to get the banner on the server, and that's what this one's about. The other one above is just it's going to issue the ping command, so you can see the for and the do, and then the actual command that it's going to fire off. An ICMP ping flood. This is another type of attack. It's a basic denial of service attack. It floods victims with so many requests that the system is too busy to answer other types of requests. It's an older type of attack. Many basic security devices will protect against this attack today. It may still work, again, in industrial environments or highly specialized environments where they didn't buy the COTS technology that everyone kind of uses. So if they're kind of re-rolling or rolling their own or reinventing the wheel, you may find some devices that'll be susceptible to this type of attack.